For problem number 3, if it takes 1.6 times 10 to the negative 5th joules to move a positively charged particle between two charged plates, what is the charge on the particle if the plates are connected to a 6-volt battery? And then part B for that is, was it moved from the negative to the positive plate? And so let's start with part A. So we got to list what we know. So we had to move a particle, and it took 1.6 times 10 to the 5th joules. Well, to move something requires some sort of force. In this case, it's an electrical force that does the moving, but it moved at a distance. We don't know what the distance is, but it did move it. So this is actually work. Okay? And then the question says, what is the charge on the particle? So whenever we talk about a point charge, we're looking for either lowercase q or capital Q. But it's just one particle, so we say lowercase q. Capital Q is like the sum of charges, usually. If the plates are connected to a 6-volt battery. Now, whenever you see 6-volt battery, this is just a voltage. So what do I have? I have work that is 1.6 times 10 to the negative 5th joules. I have a charge. I don't know what that is. And then I have a change in voltage. And the reason for that is the particle, we can make the assumption that originally the particle may not have had a charge, because we're talking about putting a charge on it. So the change in voltage, whether it had a charge or not, the change in voltage, or the voltage added to the system, will be 6 volts. Okay. So even if the particle had a charge, we applied 6 volts to it. And so anyways, what they're asking us is, what is the charge? So the relationship between work and charge and voltage is W is equal to Q times delta V. And so if I solve this for Q, I get Q is equal to work divided by delta V. And we know all these numbers, so really I think we just plug them in. 1.6 times 10 to the negative 5 joules all over 6 volts. And if I crank through that and plug that in my calculator, I should get, let me double check everything, 1.6 times 10 to the, yeah, I should get 2.7 times 10 to the negative 6 coulombs, right? Because coulombs is charge. And then, or I could write this because it's 10 to the negative 6, I could say 2.7 micro coulombs, right? So remember that micro, this is the Greek letter mu, is the same as 10 to the negative 6. Okay? So this is our final answer. Now part B says, was it moved from the negative to the positive plate? Well, for a positive charge, it moves from negative to positive. Since positive work is done by an external source, the positive charge has a higher potential of energy after the move. So the answer is yes. Okay. Why? Because we had positive work that was done by an external source, so the positive charge has a higher potential energy after the move.